Let's walk through an example to show how to use information about extra revenue and extra cost to identify the optimal quantity and the maximum profit. The example supposes that the amount of output that a firm can sell in the short run depends upon how much L it employs. The table below, where we're going to develop a table that shows the relationship between L and marginal and average product, all else equal. It also shows how much output L can produce at each level of employment. Fixed cost is equal to $500. Output is sold at a price of $5 in a competitive market, and L is purchased at a price of $75 in a competitive market. So in our table, L goes from 0 up to 10. Output rises from 0 up to 470. Extra output goes down from 100 to 2. And average output, yes, it always decreases. It decreases from 100 down to 47. To find the optimal quantity, we can first fill in the column or calculate the extra revenue generated as employment increases from 0 to 10. The extra revenue equals the product of the extra output and the price at which the firm sells its output, because the price of output is constant. Let's look at what happens when L goes from 0 to 1. Output increases by 100, so the extra revenue is going to be the extra output 100 times the price of output 5. The extra revenue is $500. When L goes from 1 to 2, output rises by 80. 5 times 80 gives me extra revenue equals $400. We continue that process. We see that extra revenue decreases from 500 for the first unit of L down to $10 for the 10th unit of L. Once we found these extra revenues, finding the optimal quantity is simple. The firm wants to employ an extra L if the extra revenue exceeds the extra cost, and does not want to employ an extra L if the extra cost exceeds the extra revenue. Since the wage is constant, and we're also assuming negligible hiring and training cost, the extra cost of employing an additional unit of L is $75, the wage paid for each unit of L. With that information, we can very quickly determine that the optimal value for L is 8. The extra revenue exceeds $75 for the first, second, third, fourth, fifth, sixth, seventh, and 8th unit of L. All those numbers in that table are above 75, but the extra revenue is below 75 for the 9th and 10th unit of L. The maximum profit is 1,180. You can check this by computing profit for every row in the table. To find that number, all we've got to do is compute profit when L is equal to 8. We know L equals 8 maximizes profit. We can plug in into a profit formula. Profit is total revenue less total cost. Total revenue is price times output. Total cost will be what we pay in wages for each unit of L times the employment of L minus our fixed cost. 5 times 465 minus 75 times 8 minus 500 gives us $1,180.